Hi, I'm Sarah Tilley from Curious Maths. I'm a primary maths consultant based in London and I've been in education for over 20 years. This is my fifth video in the series of Build It, Draw It, Write It, Say It. It's a fantastic approach for teaching primary mathematics. I'm a really big fan and I've worked on it for years and years, and I've used it so many times in the classroom and it just works. So I'm really delighted to be able to share it with you. And in this video, I'm going to concentrate on how we build towards and draw towards using a formal method of short multiplication. I hope you find it useful. Here are the national curriculum objectives in England for short multiplication. In Year 3, children need to use the times tables they know and begin to multiply two-digit numbers by a one-digit number, and they progress towards that formal method. In Year 4, children multiply two-digit numbers and three-digit numbers by a one-digit number, and they have to use that formal written layout of short multiplication. And in Year 5, they continue to practice it with up to 4 digits by one digit, but then they move on to long multiplication. So what's the point of using this approach? Well, I think it gives the children a fantastic concrete experience, and this is really important if we want children to understand what's actually going on in the maths, if we want them to see the structure. It provides a scaffold when learning a new method, and a lot of children are intimidated by written methods, so the build it and the draw it really help them build their way towards it. This supports memory retrieval, they're bound to remember more if they're active, and it makes connections with previous learning on multiplication. By doing this and getting them to capture what they've done practically in the maths book, it helps the maths books to be revision guides, and it lends itself beautifully to reasoning because they've got something they can write about. Here's an example of a template you might like to use if you're using this approach, and it works well for pairs or small groups, especially if you do it on A3 and get it laminated. By doing it like this, it does help structure the learning across the week, and children get that overview of where the maths is going, what they've learnt and what they need to practice. But as for the approach, you can always start with a build it, that's really important. But as you'll find in this video, it might be that you do a build it and a write it at the same time, and a draw it and a write it at the same time, or a build it and a draw it at the same time. It's a really flexible approach, so just think about what your children need. Just to mention that if you are struggling with manipulatives in the classroom or at home, there are some great websites to support, and I'm a big fan of MathSpot. And this is an example of how you can use the place value counters as virtual manipulatives online. There's also another great website called Toy Theatre. So if you're struggling to be able to demonstrate from the front of the class, do look into these virtual manipulatives websites. They are so useful. So before I start showing you how you can use the build it, draw it, write it, say it approach for short multiplication, it is worth you checking your calculation policy, because there are a variety of different ways that you can go on the journey to short multiplication. So some schools use the grid method as a step to short multiplication, some use the expanded method as a step to short multiplication, and some schools go straight in to short multiplication. The reason why it's worth checking is because you may want to pick carefully which one of the builds and draws I show you today, because it's really important that your draw in the book, what the children capture, replicates the build. So making sure the manipulatives match, and making sure they match the models and the methods of the written form. So I'm going to show you a range of questions from years 3 to 5 using building up to a short multiplication method, and the types of build and draws that I would do for them. And then you can choose from there which one best fits your school policy and actually best fits what your children need. Let's look at the build if you're using a grid method in school on your journey to short multiplication. So as you can see, this very much replicates the grid method, and that's what we're trying to achieve. So I have made my 22 3 times using base 10 or Deans, but I've also done it in place value counters, so you can choose which one you find most useful. Now putting them like this is really helpful because in Key Stage 1, children will have made arrays when they're looking at multiplication and division facts. And rectangular arrays seem easy to understand for the eye, and children will recognise this, so it works really well. So just like I will do when I get to my formal method of short multiplication, I'm going to start in my ones column. So that's this part here and here. So I've got 3 lots of 2, which equals 6, and I can count my base 10 or my place value counters and fill this in. So it might be a nice idea to do the write at the same time as the build. And here I've got my 23 times. How much have I got altogether? I have 60 altogether, and I can count 10, 20, 30, 40, 50, 60, or we can encourage them to count in 20s, whatever they need to do. And then we fill the numbers in the appropriate parts, and then we find the total and see how many we've got altogether. And we can see that 22 times 3 equals 66. And this very much matches because we've partitioned, we can see our 60 and we can see our 6. This build also works perfectly if you're using an expanded form before you move to short multiplication, because once again we can see the 1s and the 10s quite clearly, and children can use their build to fill in the parts. So we start with the 1s, 3 lots of 2, we have 6. 3 lots of 20, and we want to be very clear that it's 3 lots of 20, and our build actually really reinforces that. 3 lots of 20 is 60, and some children might count in 10s, some children might count in 20s to see how many they've got, and we can see that when we add them all together, we have 66. Let's think about the grid method and the expanded form as a draw it. So it replicates the build we've just done with the base 10, and it's really great because if you've got squares in your maths book, the children can actually count out the 2 lots of 10 to make 20, and then the 2 1s. And then as you can see, this draw will replicate exactly what they have done with the build. And alongside the draw, I would be doing whichever form you do in school, whether it's the grid method or the expanded method, and children will be talking about where they can see on the draw the maths in the question. This is the build that I would use if I was going to move straight to short multiplication. So if my school calculation policy doesn't have a grid method or an expanded form, this is how I would do it. Now I am a big fan of having the deans and the base 10 or the place value counters still at this stage, particularly the base 10 because it's countable and it is still useful for children to be able to do that. So what you can see here is that I've built 22 3 times, and I'm going to move to my write it, and I'm going to do it at the same time. So I've got 3 lots of 2, which is 6, and then I've got 3 lots of 2 10s, and now I'm asking how many 10s have I got? Because I'm in my 10s column, I have 6 10s. So 22 times 3 equals 66. This is the draw it that goes with the short multiplication build I've just done. And as you can see, it's very, very simple to replicate in the maths book. And I've shown it here with both base 10 and place value counters. And alongside the draw, I would continue to do the write it. And I would also think about not only ensuring children are saying it and using the language all the way through the build and the draw, that they actually capture in the maths book the way they would explain it to somebody else. This is a harder question, 234 times 3, and it is harder because if you were using the short multiplication method, you would need to do some regrouping. However, if you're using the grid method or area method, then you don't need to regroup because we actually put how much is in each part and then total it. So this is the build I would do if I was using a grid method on the journey to short multiplication. And as you can see, I have built what we can see in each column. So I've got my 12 ones, I've got my 3 lots of 30 and my 3 lots of 200. And I still would start in the ones column when I'm writing how many I've got, and I would move across to the hundreds column because of course when they do move to short multiplication, that is what they're doing. This build works equally as well if you're using an expanded form, because once again, you're not regrouping, although there is some regrouping when you're finding the total, but you're still representing these parts as you see them. So I've got my 12 ones, my 90 10s, and my 600s. And children will have to have some understanding of columnar addition and what happens when we regroup to be able to use this method. But we can see that we've got 702. This is the draw it that matches the build we've just done, and this is what we want the children to replicate in their books. So if you've been using place value counters, that's how I would do it, but you could also do the same using base 10 or deans. And this draw it could be captured in the book alongside whichever method you use on the journey to short multiplication. So this is your grid method, which matches perfectly to the draw and the build. And here is your expanded version, and all these values are easily identifiable to get the total. If you're going straight to a short multiplication method, or even if you've done the other stages and now you're at the short multiplication method, we do need to address regrouping. And that's why I really like this approach, because the build it, draw it, write it, say it gives us an opportunity to really unpick the structure of the multiplication, but also give children a hook and a way to calculate if they're not sure what to do. So just like before, we would start in the ones column. I've got 3 times 4. And we know that 3 times 4 is 12, so I'm going to need to regroup. And if you're doing questions like this, you'll have already talked about regrouping with addition and subtraction. So I'm going to regroup 10 of those ones for one of those 10s. And at the same time, I can show what this looks like in my right. So I have 2 ones remaining, and there's my regrouped 110 that I need to add to the 10s that I've got. So how many 10s have I got now? Well, I've got 3 lots of 3 10s plus 1 more 10. I have 10 10s remaining. So I need to do another regroup. So I'm going to exchange those 10 10s for 100. So in my 10s column, I can see I've got 0 10s. I cross that off because I like to do that because I know I've added it. And now I can regroup that 100 into the hundreds column. I've got 3 lots of 200 and another 100. How many hundreds have I got? I have got 700. I can cross that off to show that I have done it. So 234 times 3 equals 702. This is the draw that would go with the build that we've just done. So we want children to capture that build as a draw in the book. So it's really important we make sure that we give them an opportunity to show that regrouping if they're using the short multiplication method. So it's the same question, so I'm going to go through it very quickly. We know that 4 lots of 3 lots of 4 are 12. So we regroup our 10 ones into 1 10. And we can show that here we have 2 remaining, and here is our regrouped 110. Now we go to our 10s column, 3 lots of 3 10s plus 1 more 10. How many 10s have I got? Well, I've got 10 10s. So once again, I need to regroup those 10 10s into 100. And I can go back to my written method and see I now have 0 10s when I've added that, and I've regrouped into one of those things we call hundreds. So now we have to do 3 lots of 200 plus the other 100. How many hundreds have we got? We have 7 hundreds. And I like to cross that off to show that I've added it. And if it's useful, we can also write the 2. We can put the 0 there, and I do find this quite useful because sometimes, particularly if you've exchanged and you're going to end up with a 0, it can be hard to tell that there's 0 left. So that's quite handy. And then I can put my 7 there. And that's how we would match the build to the draw it to the write it in the maths book. And this will provide a really good memory hook. And all the way through that, if they're doing partner work, they can be talking about it, using the say it part, using the correct language and describing what they've done. And all of this will add together for them really being able to remember more. Here is a draw it example of a 4-digit number multiplied by a 1-digit number. And this question, in schools in England, children will be doing this type of question in year 5. And actually, this is as hard as it gets for the short multiplication, because during year 5, children will also be introduced to long multiplication, a 2-digit number multiplied by a 2-digit number. And of course, that has a slightly different method. But all the work that you have done with the build it, draw it, write it, say it on short multiplication will definitely be useful when they move on to long multiplication. So I've decided to draw it because, as you can imagine, as the numbers get big, you need a little bit more space, and due to filming, I haven't got a lot. In the classroom, this might be a paired activity because it does take up space. And you could also think about using place value counters because they don't take up quite as much space as base 10. But it's still really important to allow children to build it and draw it. So this is the image they might capture in their maths book. I know the thousands make people cringe a little bit, can be hard work, but the children are in year 5 then, so you should be able to teach them that old classic of drawing 2 squares overlapping and then joining the vertices up. So that will be an option. Right, let's look at this question. So I'm going to do it with the short multiplication method next to it. Again, as I've done for the others really, I think the write it works really well with the draw it at the same time. So 4 5s, well I can see my 4 5s are here and I know that 4 5s are 20, and if I don't know that I can count it. And 20 is made up of 2 10s, which I need to regroup. So what I have here is 0 1s, and I'm going to regroup my 2 10s. And that's where the 2 appears in the short multiplication written form. So now we're going to look at how many 10s we've got. Well, we have 12 10s, 13 10s, 14 10s. So we need to regroup. So I'm going to take 10 of those 10s and regroup into 100. Now that means I've got 4 10s remaining, which I can put here. I can cross this 2 off because I've added it, and I can show my 1 regrouped 100 underneath, not by there. So now we have got 100. So we have 4 lots of 0 100, but actually we have regrouped, so that 1 can now go there. Now we multiply our thousands column and we can see how many thousands we've got. 2, 4, 6, 8. We have 8 of those thousands. So we have a final answer of 8,140, which matches our written method. So as I've said before, that's as hard as it will get in primary school in schools in England. So work with your children on short multiplication using this method, right up to 4 digits to 1 digit, but then children will move on to that long multiplication method. I really hope you found this useful. I'd love to know that you were trying it out with your class. I am seeing it in action in lots of schools at the moment, but I'd love to hear from you if you have a go. So if you like this video, please give it a like and subscribe to my channel, and head over to my Curious Maths Facebook page for more primary maths fun. Thanks very much for watching.